Hello, welcome back to your math class. We are doing section 9.2.2 today, called How Can I Slice It? It gives you an idea what we're going to be doing. We're going to talk about something called cross sections. A cross section of a three-dimensional solid, you know, like a pyramid or prism or cone, that kind of thing, is the figure that's obtained when the solid is intersected or sliced by a plane. A plane is a flat surface like a sheet of paper. Today you will investigate the shapes that you can be created by slicing various types of solids. Sorry. Okay, so watch this little video. Whoops. I just lost that part right there. Let me bring that back. I have my video pan. Okay, good. So, let me try that again.
Math shorts.
Slicing solid, three-dimensional figures results in different two-dimensional shapes, depending on how you slice them. If you cut through a cylinder with a geometric plane parallel to the cylinder's base, the two-dimensional cross-section is a circle. Any way you slice it, you can get two-dimensional shapes from three-dimensional figures. When you slice a cylinder from top to bottom that is perpendicular to its base, then look at the cross-section straight on. You get a rectangle. What happens when you slice a square pyramid? If you slice across the pyramid with your plane parallel to the pyramid's base, the cross-section is a square. If you slice with your plane perpendicular to the pyramid's base, the cross-section is a triangle. Remember, you're slicing a solid, three-dimensional figure with a geometric plane. You can slice in any direction. Just keep in mind that shapes can look different when you look at them from different angles. So orient the cross-section on the geometric plane. Slicing diagonally can produce different shapes, such as an ellipse or a trapezoid. Understanding the two-dimensional shapes that result from slicing solid, three-dimensional figures is important for geometry and ninjas.
So that's what we're going to be doing today. We're going to be looking at finding cross sections, how you slice it. So really quickly, if you want to take a check at your homework, I'm just going to zip right through this, and then you can look at it by pausing and starting and pausing and starting. Okay, take a good look at how I did those problems, and then if you got something wrong, look at my explanation, double work through it, figure out what I'm writing. All right, so 961, students will use, before we do this, students will use Chromebook and GeoGebra activities instead of clay and a plastic knife or string for these activities. So ideally, if we were in class, we would be using modeling clay and like dental floss to cut these things. But because you're at home, we're not going to do it that way. In fact, I found some really cool tools on a website called geogebra.org, and we're going to use those tools, which will do exactly the same thing. In fact, it'll be easier than if we were actually using the clay and the string. So here's the problem, 961. Make sure you get enough sleep. Using clay, make a rectangular prism or cube. An example is shown below at the right. Each person in your team should make a slightly different prism. Part A, use your string or plastic knife to slice the rectangular prism by holding it tightly and pulling it through the solid. An example is shown at right. Place your newly created face made by the slice that came from the inside of the rectangular prism on the paper and trace the results. What is the name of the shape? So they're just having you cut straight down on that. So if I were to open this tool up here, and hopefully you can see the tool, if I were to take and I'm going to rotate this vertical and I'm going to slice straight down through this plane, you can see that this shape that we get inside of there is a rectangle. That slice forms a rectangle. If this were a shorter object, like a square, like a cube, then the inside would be a square. Now, what's cool is these tools let us do some rotating this way, and they let us rotate in the vertical direction, and they let us take this thing higher or lower, and you can move it front to back, whichever direction, until it's lost. You can make the plane a little darker. You can make the object a little bit darker or transparent. So it kind of gives you a lot of little tools to work with. So my answer for the first part of this problem is what is the name of the shape you get? I got a rectangle with mine. If you have more of a prism, cube shape, you'll probably get a square. So let's look at problem 961B. Which of the following shapes can you make by slicing your prism in different ways? Before making a new slice, reshape your prism. Well, we won't have to do the reshaping part because ours is all digital. But they want to know which of these objects is it possible to make using that tool. So if I go back to my tool here, is it possible to make a triangle? So we're going to start with a triangle. If I were to take this and I don't know, let's rotate it a little bit this way, and we'll rotate it a little bit this way, and we'll look at it. Is that a triangle? Now, that looks like a trapezoid. Look at that. Whoop, I just had it right there. Can I make it so you can see it better? Well, you can see it. Here's the two parallel sides. So that looks like a trapezoid to me. So if I were to take that and set it out there, you can kind of see it pretty good. If I were to rotate that a little bit more, is that a triangle? No, not a triangle, but that is a, looks like a diamond, almost like a diamond ring. It's got 1, 2, 3, 4, 5 sides. We call that a pentagon. Let's see, what if I were to make this go lower? Still a pentagon, still a pentagon. Oh, look at that. That looks to me like a triangle. Does that look like a triangle to you? Yeah, we can do a triangle. So we just did a triangle and a pentagon. Let me take that back down. I have an idea. What if I go really low with it? And I tilt it up just a little bit. What shape do I get now? How many sides does that have? Let me make this a little bit better. Nope, I think that's just about as good as I can get it. Anyway, that's going to have 1, 2, 3, 4, 5, 6 sides. We call that a hexagon. So we were able to get the triangle. We got that triangle when we moved this way up. Actually, how did we do that again? I forgot. Oh, we moved the height. Took that up here. There's triangle, 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 triangle. As soon as it hits that corner, you see how it created a new side? So, oh, there's a trapezoid. Here is a hexagon. Here is a pentagon. So it looks like I've been able to get 3 sides, 4-side trapezoid, 5-side pentagon, 6-side hexagon. The most that one plane could ever touch a 6-sided object would be 6 different sides. So I think the hexagon could be about as big as I could get. So now let's go back to our question here, and we'll just see which ones we think we can actually get on here. So triangle, can we get a triangle? Well, I think the answer to that one was obvious. Yes, we could get a triangle. Work with your team before making a new slice, reshape your prism. So which of the following shapes can you make? We were able to make a triangle. Yes. A square. Well, I think that depends on the shape. If this end was a square and I were to cut straight through here, wouldn't that basically make a square for me? So when I cut that like a cube of butter, right? When you cut a cube of butter, this piece that you're going to get right here is going to be a square when you look at it front ways. Now, so I think we can get a square. I know we can get a rectangle. If you cut that thing this way, well, you can see the top. See how the top's a rectangle? So is every single layer. Every layer is a rectangle wherever you cut it. So I think we can do that one. So we have a triangle, square, rectangle. I saw a trapezoid on the program we did. What about a parallelogram? Parallelogram. Can we do a parallelogram? So first we got to get it into a quadrilateral. Oh, wait a second. There's a parallelogram. Turns out all rectangles are parallelograms, right? So there's definitely a parallelogram. If you can get a rectangle and a square, you can get a parallelogram. See all those? Those are all parallelograms. Actually, that's more, a little bit more trapezoidal. I probably have to rotate it. There's one corner. I don't know how to get that to go. Oh yeah, I do, right here. Okay, so now we got a nice rectangle there. And then we were able to see also that that rectangle is a parallelogram. So I'm going to go ahead and we'll count that one as a parallelogram. I showed you the pentagon and the hexagon. Can we get an octagon? Well, if you have 6 possible sides, the most a single plane can ever touch 6 possible sides is if they could touch all 6 of them. We showed that when we had the hexagon. So the most we're going to get is a hexagon. So I could say that the octagon is no. And can you get a circle? Can you cut it and get a circle? I doubt it very heavily because all the faces are flat. Therefore, you're not going to get a circle. So we can get all of these shapes depending on what our prism actually looks like. That's kind of cool. That's what a cross section is. Now, doing that without a computer is actually pretty tough. I have a very hard time personally seeing what the cross section is going to look like. I have to experiment with it. So the computer tools that you have are really fun. And I want you to go experiment with that tool that I linked. And I want you to see if you can get all of those shapes that I have checked. I want to try it out. See if you can do it. Not as easy as it looks. If I go completely horizontal, you can see the square there, right? Even if I rotate this around, I can still have a square. No matter how high, how low I cut it, it's always a square. Oh, there's an image of how volume is calculated. If you take that square base and you raise it up through all of the layers, that's going to make a volume. Base area times the height. It's kind of cool. Now, let's see what else we got going on here. So that was 61B. Problem 61C, even though each team member had slightly different rectangular prism, were you able to create the same cross sections? Were there any shapes that one team could create and another could not? Well, since you were working with me, I think we created all of them. And when you played with that tool, the digital tool, you should see if you can make all of them too. Spend a little time with it. It's kind of a cool thing. Problems 962. Now make a rectangular pyramid. For example, an example shown it right. Again, each person in your team should make a slightly different pyramid. Use your string as a cutting tool, as you did in 961 to slice the pyramid. Place the newly created face that is made by the slice that is made by the slicing came from inside the pyramid on your paper and trace the resulting shape. What is the name of your shape? So they say use the strings you did and slice the pyramid. I'm going to look ahead here, but what other shapes can you make by slicing the pyramid? What shapes are impossible to make? How do these types of shapes that you can make with a rectangular pyramid compare to the types of shapes you made with a rectangular prism? All right, so let's check out the digital tool that belongs to this one. Go here. The guy who wrote these things, his name's Anthony, and he did a really cool job with it. So here's our rectangular pyramid. And first thing I notice is that if you go all the way to the top and then start bringing it down, right away, there's a first little rectangle. Do you see all these little rectangles? So horizontally, it's going to cut into a rectangle. No matter how you look at it, it's still a rectangle, right? It looks almost like a square, but the base is more rectangular. Now, I know I can get it to touch 4 sides. Can I get it to touch 3 sides? Well, let's go vertical. So when I go vertical, is that a triangle? Nope. But maybe if no, that didn't do it. Maybe if I slide, oh, I know what I have to do. I have to slide it frontward, backward. Right there. There is a triangle right there. So you can see it pretty good. Right, see the triangle? So I know I can get a triangle. I know I can get a square or a rectangle. So that's 3 sides, 4 sides. What other shapes can we get? I think I gave one of them away a second ago. So let's see here. If I move this backwards just a little bit, you see how this is parallel to that, and these 2 sides form the shape of a trapezoid. See the trapezoid in there? So that's interesting. I'm going to make that a little less. And then what if, so that's 4 sides, that's a trapezoid. So I have rectangle, I have trapezoid, I have triangle. Can I get 5 sides, a pentagon? So this shape has 4 triangular faces around the outside and a rectangular base. Is there any way to cut it so that I hit all 5 sides? So I need to cut through here somehow. Let's see how to do that. Is that possible? I think it is. There it is right there. You see how I'm touching all 5 sides? I have 1, 2, 3. Oh no, that's only 4 sides. But that is not a parallelogram. That is that's just a quadrilateral. So let's see. How about if I rotate it more? No, that didn't help me. There's 4 sides. Can I hit the 5th side? How do I do that? 3, 4. See, I'm having to even experiment with this myself. Nope, that didn't help. Oh, there it is. Look. Okay, so now you can see I've got 1, 2, 3, 4, 5 sides. Depending on how I set it up will determine what shape that is. If I lower this down, oh, you can totally see it now. There's my pentagon. So I know I can get triangles, rectangles, trapezoid, pentagon. Can I get a hexagon? Well, a hexagon requires it to hit 6 faces, and since there's only 5 on a pyramid like this, a rectangular pyramid, I'll never get 6. I'll never get 8. Can I get a circle off of this? Probably not. So I'm going to go ahead and say here, let's see, for part A, I guess my first shape was a rectangle. And what other shapes can you get? So we got trapezoid. We got just a regular quadrilateral. It didn't have anything parallel. Quadrilateral. quadrilateral, I think it's quadrilateral, there you go. Quadrilateral, comma. We got a pentagon. We got a triangle. Oh, way back at the beginning, I was able to hit 3 sides by cutting it vertically. And I think that was it. So this is the shapes that we can make. The shapes that we cannot make, no hexagon or bigger. And no cylinder, and no circles. No circles. So that's kind of a cool tool. Again, I want you to go back and experiment with what it takes to make all these shapes. Try it out. It's not as easy as it looks. And if I give you a tool like this and something to do this with on the test, you're going to want to have had time to experiment with it. Okay. All right. Problem 963, cross sections and volume. In lesson 921, you learned that volume of a solid is found by determining the number of cubes it takes to create the solid. A, make a rectangular prism similar to the one you made in 961. How can you repeatedly slice the prism so that each of the slices that you create is the same size and shape? Oh, I just got a big mosquito. Discuss this with your team and then slice your prism into equal pieces. So depending on how big you make the first slice, if you want to cut something up like into 6 equal parts, then you have to carefully cut it into 6 equal parts. But when you go the other direction, your parts have to be the exact same size because you want the pieces to be cubes, little tiny cubes. So that means you have to think carefully, how can I divide this side up and this side up and this side up so that each of these little corner pieces is the shape of a cube like that. So make the prism. How can you repeatedly slice the prism so that each of the slices that you create is the same size and shape? So you just have to basically be careful that you're cutting everything the same size in all directions. Kind of like cutting a cake. You have to carefully cut congruent slices to get those squares. You will have to make cuts. It's kind of weird. If I'm cutting a cake this way, and I'm cutting a cake this way, that's easy, but we never think about cutting the cake this way, right? We don't ever cut the layers, but they're actually suggesting that you do. Okay, and what they're talking about would be something like this. I mean, if you were to cut it correctly, you could get 3 layers out of this, and each of those 3 layers has 6 squares this way, 3 squares that way, and 3 squares high. So that should help us figure out the volume. Visual of this comes from this activity. I can't do a 6 wide, but I can do 5 wide this way. See how I'm making this here, and I can do 3 wide that way. How many pieces, if it's 5 by 3, how many pieces would fit on this piece? Now, if I took those 15 pieces and I layered them 2 layers, and then 3 layers, and then 4 layers, if I have 15 on the bottom and I have 4 layers of 15, that would be a total of 60 cubes. So the trick to the math we're doing today is we want to find the number of cubes that are in the base area, and we want to multiply it by the height. Now you got to be careful because the base is not always the thing it's sitting on. In this case it is, but we'll talk about that more in a little while. So part B, take one of your slices and cut it into cubes of approximately the same size. How many cubes are in the slice? So we're going to cut the bottom layer into cubes like I did right here. And how many cubes are in one slice? They want to know how many cubes are in the bottom layer. So if this has 6 by 3, how many cubes are in my bottom layer? So the base area well, I'm going to put that in parentheses. The base area has 18 cubes. Part C, use the number of cubes from a single slice of the prism and the number of slices you created. How many cubes would it take to build your prism? So if we were to take those 18 and we were to do that for 1 layer, 2 layer, 3 layers, 1 layer, 2 layer, 3 layers. So if you had 18 on the bottom and 18 in the middle and 18 on the top, how many total cubes would you have? So your volume would be 3 times 18, which is 54 cubic units. And that's how you state volume. You state it in cubic units, like cubic centimeters, cubic inches, cubic miles, whatever. Okay, cubic miles would be huge. Problem number 63D, find the volume of each of these prisms. Make sure everyone in your team agrees with your answers. And remember how many layers and how many cubes are in each layer. So if we look at this bottom layer, how many cubes are in this bottom layer? Just this part down here. Looks to me like we have 3 by 2. So the bottom layer, if I had to find the volume, I would take 3 times 2 for the base, and then we're going to multiply that by the number of layers. How many layers high is this? Looks like 2 layers high. So the volume is going to be 6 times 2, which is 12 cubic units. Now, as the numbers get bigger, it becomes more and more difficult to draw the individual cubes. So if I had asked you what is the area of this base, how many cubes could you put across this 6 by 9 base? Then I know the volume of this is going to have a 6 times 9 base. There's going to be 54 in the bottom. And then how many layers high is this going to stand? So that's going to be times 8. So the volume of this will be 54 times 8. The volume is going to be 432 cubic units. Now I'd like you to go ahead and do the third one on your own right now. I'm going to give you just about 15 seconds. So if we're looking at this bottom rectangle here, it's 4 by 2. Sometimes you got to search for this number that matches. If this is 2, this is 2, this is 2. So the base area, this part down here, is going to be a 4 times 2 rectangle. So my volume will equal 4 times 2 times, how many layers do you see? How many layers high is this talking about? It's a 3 high times 3. So your volume is 8 times 3. The volume is 24 cubic units. Now don't get fooled. It's not always length times width times the height. It's different. It's going to change. When the base changes into a circle, it's going to be something different. When the base changes into a pentagon, you're going to have a base area for the pentagon. There's lots of little things coming up here. All right, 964. Sane, I hope that's how you say that, made a prism and placed it into equally sized pieces as you did in 963, but she is only letting you see the slice drawn at right. So this looks like the bottom slice, let's say. Draw a sketch of San's prism. So they want you to draw this in your notebook. Go ahead and pause, draw it, and then restart. Part B. Sane told you that her prism has 8 slices like this one that are each the same. What is her volume? So she's going to have 8 of these. So I guess the first question is, how many are in here? So the volume of this layer The volume of that one layer is 4. If she has 8 of those slices, 8 layers, the volume of hers is going to be 4 times 8. So the volume will be 32 cubic units. I don't think I can draw it though. Can I draw that? Let's see here. I'm going to draw it like that and like that. Oh, I can draw it. Look at that. Pretty good. So you can kind of see it here, and we have 8 layers of this. So if you have 8 layers high and there's 4 on top, that's going to be 832. So let's see if I cut the 8. I don't think I can do the 8. Maybe I can. It's not going to look very square though. There's 4, 5, 6, 7, 8. There we go. 8 layers of that. That makes a total of 32 cubic units. Pretty good. All right. Now, before you get on to that, you're going to read your math notes, and then you're going to do 965 to 970. Just a little heads up. Pretty soon we're going to be doing things like this. Like, let's say I told you you had a pentagonal prism. Looks something like this, and I asked you to find the volume of it. I'm not doing very good on my drawing here. There we go. What is the shape of the base? So if you said the shape of the base was a rectangle, you weren't listening to me earlier, because this is not the base. The base is not the thing it sits on. With prisms, the faces are rectangles. The bases could be a rectangle, but the base is the figure that dominates the shape, the one that it's named after. So when you have a pentagonal-based prism, the pentagon is the base. So this one's not standing on its base. If it were standing on its base, it would look something like the following. Now it's standing on its base. But sometimes I'm going to give you the picture not standing on its base, and you need to know that this is the base. And if I told you that the base area was equal to 30 square inches and the total height, because see how this is how tall it stands? If you were to tilt this shape up on end, it would stand, let's say this is 10 inches tall. Maybe it's standing 10 inches tall. All right, so that means that the volume is going to be the base area times the height. The volume will be 30 times 10, which will be 300 cubic inches. All right, now you can go work on 965 to 970, and we will come back to more of this tomorrow. Thank you for listening. Thanks for being a good audience.